going to begin. So our first strategy here at the top of the list is greatest common factor. And we've seen this one before. I listed this one first because we want to make sure we always check for a greatest common factor before we try any other method. And the way that this was taught and explained before is we want to try to look at our terms and find something that they all have in common, or something that they could all be divided by. And that greatest common factor could involve a number. So if we look at the numbers out in front, 2, 8, and 12, those are all even numbers, so they can all be divided by 2. That greatest common factor could also involve a variable. So if we take a look at the x's here, we see they all involve at least one x, and so we could have that as part of that GCF. So let's go ahead and begin by just showing this first step here of division. So we're going to see here that they were all even numbers, so they can all be divided by 2. They all have a single x in common, so we're going to divide everything by 2x. And what we saw before back first semester was the placement of that greatest common factor is going to go out in the very front of a quantity in parentheses. So it doesn't just disappear, it doesn't go away forever. Whatever it is that we're dividing by everything by is going to stay out in front. Now on the inside of our parentheses, we are going to be putting in the result of each term of doing that division. One little trick that we can think about when it comes to the x's here, like let's look at this first term here when we do this x to the third, and notice how it's dividing by an x on the bottom. This is really an x to the first on the bottom. Well, when we do that division, what really happens is the exponents subtract. So it's really going to be like 3 minus 1, turning it into an x squared. Another way that you can think about it is if you have x to the third, if you're dividing an x out, it's kind of like you're taking an x out of that. So now it's only going to have 2 x's being multiplied together instead of 3. And then for the middle part here, let's bring down the subtraction sign. Now in this case, the 8 divided by 2 is still going to leave us with a 4. If we try that subtraction trick, again here, this x squared divided by x to the first, well now it's going to be like 2 minus 1. So the exponent will just be x to the first, or just x. And then finally at the end here, we can bring down the plus sign, that 12 divided by 2 is 6. And then when we do x divided by x, that's just equal to an invisible 1. It's kind of like the x is just going to go away altogether. If you think about the subtraction trick, if we actually subtract the exponents here, 1 minus 1 is 0. And x to the power of 0 is equal to 1. So we don't even have to write an x for that part. Now, it's very possible that once you take out the GCF, you're able to use one of the other factoring methods to go a little bit further. In this case, though, it looks like the trinomial part will just have to leave it as it is. Now, this is kind of getting into the next method, but we've done a lot of work with these throughout the year, so hopefully your mind is already starting to think a little like, could we find 2 numbers that multiply to 6 and add to negative 4? If we start to think of some numbers, it just doesn't seem that it's going to work out. So if that's the case, we just leave it as it is, and the only thing that we were able to do was the GCF. All right, second method. This one should look and feel very familiar. This is our basic trinomial. So notice it is a trinomial because it has 3 terms. And it's a basic trinomial. We say if a is 1, meaning the number out in front of the x squared part is just a positive 1. A lot of times it's invisible. That's where we can think about using this basic trinomial method. So this is where we like to draw that little x diagram. In this case, we want to find what multiplies to 12 and adds to 7. For me, sometimes it's a lot easier to think of these numbers than others. In this case, what are 2 numbers that could work?
3 and 4.
2, 3, and 4. So we'll go ahead and put them here on the side. And we know that this is going to look like 2 parentheses side by side. We'll put in a single x in front, and it's a positive 3 and a positive 4. So we've got x plus 3, x plus 4. All right, now we know from the past that not every trinomial has a 1 in front of the x squared. So what we're going to move into on the next problem is an example of the slip and slide method. We are going to need to use this if A is something other than 1, and also that it's not a greatest common factor. So that's always a good little thing to check. So in this case, for example, because we have that 3 in front of the x squared, we can ask ourselves, well, could we just divide everything by 3? And if the answer is yes, just take out the 3, and then it turns it into a basic trinomial. But in this case, we can't divide everything by 3, and so we are stuck with it, and this is where we are going to do that flip and slide method. So it's been a little bit of time since we've done this one, so I just want to remind you of the process. This is where we're going to start by taking the term out in front, that 3, and we're going to multiply it by the term at the end. So we say it's going to flip to the end by multiplying. And it's going to turn it into a brand new trinomial altogether. It actually turns it into a basic trinomial as soon as we get rid of that number in front. And just for a moment here on your own paper, I want you to go ahead and factor that basic trinomial and just write down on your paper what you get when you fill in your parentheses. If it's helpful for you to think about filling in a little X chart like this off to the side, you can do that. All right, so I might start to fill this out like this. So I want to think about two numbers that multiply to negative 12, but add to positive 1. Benjamin, what numbers did you find?
So this time I got positive 4, negative 3.
Beautiful. So we've got x plus 4 and x minus 3. Now, even though we have our nice parentheses here, we're not all the way finished yet, because if we were to multiply this step out with FOIL, it's not going to turn it into the same thing that we started with. It's just going to turn it back into this little in-between step. And so this is where we need to add a step here. That's going to be taking the 4 and the minus 3, and we're going to divide them both by whatever number we multiplied over in the very first step. So in this case, we multiplied over 3. This part of the process is kind of like undoing that step of multiplication. So each little factor part gets divided. And the fractions that result here, we always want to make sure that we simplify or reduce those fractions down as much as possible. Now, sometimes it's going to simplify down to a nice whole number. That's going to happen to us right over here on the second one, in which case just leave that as it is. So that factor in parentheses is going to be x minus 1. Other times the fraction simplifies, like 4/3 is already simplified all the way. But let's say, for example, on a different problem, we have something like 8 over 6. Well, we would want to go ahead and simplify that to 4/3 before we do this final step. So with the 4/3, our final step then is we're going to take the little denominator part of 3, and that's going to slide right over here back up in front of the x part. So that parenthesis will be 3x plus 4. And if we were to do a little quick check here with FOIL, we can see on this one that 3x times x is 3x squared. The outside term would be minus 3x. The inside is plus 4x. And the last term times the last term is going to turn it into minus 4. Sure enough, that is going to simplify to the exact trinomial that we were given at the very beginning. All right, the next method that should look familiar is difference of squares. So the format of this is very unique and special. We know that it only has 2 terms, so technically it's just a binomial, but it looks like it's missing the middle term. So it's just going to be an x squared term at the very front. It has to be subtraction, so subtraction is where we get the word difference. And then it has to be a nice perfect square number here at the end. In fact, both of these are perfect squares, which is why it's the difference of squares. So up above, if we were to generalize this, a squared minus b squared, it is still going to factor into two parentheses side by side. And this is the one where we took the square root of the first term and we listed it first. We took the square root of the second term and we listed that second. And then we want to make one symbol a plus sign and we need to have the other symbol a minus sign. So the reason those symbols have to be opposite signs in this case is so that when we FOIL it out, we want to have the outside terms cancel out with the inside terms. That's why there's no x terms that are in the middle. So that's the importance of having the opposite sign. So on your paper, I want you to go ahead and factor x squared minus 25. All right, so I would start by thinking here about taking the square root of x squared. That's going to give us an x in front. We'll take the square root of 25 to put a 5 at the back. And just make sure that you have one plus sign and one minus sign. If you were to FOIL it out, for the outside term, you're going to get negative 5x. For the inside, it's positive 5x. When you put those together, they're going to cancel. That's why we don't have a middle x term when it's all the way multiplied out. All right, so those were our four methods that should have looked familiar to you from first semester. We are going to move into some new methods. So we just talked about difference of squares. The next method that we are going to look at actually involves the sum or difference of cubes. So meaning values that are raised up to the third power. There's a couple of ways that this can look. In the first one here, it could be a cubed plus b cubed. That would be a sum because it's addition. The other option is a cubed minus b cubed. That's going to be a difference because it involves subtraction. And so there's a special way, a special little formula for how we can expand these out in factored form. It's kind of like the formula that we wrote out up here on this one, but it's a little bit more complex. There's a little bit more to it. So the first one here, the a cubed plus b cubed, it's going to start with a binomial multiplied by a trinomial. And so inside of the binomial, we're going to fill in a regular a plus b. So technically, a would be the cubed root of the first part. B is the cubed root of the second part. And notice how the symbol is the same. So in that first parentheses, it's the same plus sign as we had originally. Now let's talk about the trinomial part. So that is going to start with a squared. Then we're going to subtract a times b. And then at the end here, we're going to add b squared. So when it comes time to expanding out the second one, which is the difference of cubes, these 5 elements are actually the same as what they were for the first one. The only difference is going to be the symbols that you have in between. So the plus and the minus signs are going to look different, but it's still going to begin with an A and a B. Over here, it's going to be a squared, AB, B squared. So those are the 5 elements that I think about when I start to fill this in. And here's what the symbols are going to look like for this one. So it's first going to start now with a subtraction sign. So again, notice how it's the same as the original sign. Then it's going to be a plus sign. However, for the very last one, it's still going to be a plus sign. So if you think about a number being squared, when you square a value, the result that you get is always going to be positive. So even though it seems like the other two symbols are just opposite of the first one, the one at the end is always plus. And so actually, I have a little helpful way to help us remember and think about what symbols go where. So as long as you can get the basic setup that looks like this, so we need to know those 5 elements, here's a little acronym that's going to help us to remember the symbols. It's called SOAP. It sounds a little weird, I know, but I think of these as the SOAP formulas, and here's what it stands for. We're going to draw some little arrows here. So underneath this first column of symbols, we're going to write that that symbol is the same as the original. So the S in SOAP represents same. So notice how in the first one here, it was a plus sign because the original was a plus sign. Down here, this is a minus sign because the original was a minus sign. All right, underneath the next set of symbols, this is the opposite sign from the original. So the O in SOAP represents opposite. So if we check that up here, we see, yep, it turned into a minus sign. That was opposite of what we had at the very beginning. This one turned into a plus sign, which was opposite of the minus sign we had at the very beginning. Okay, and then finally, for this last little section right here, these 2 plus signs at the end, well, it is always positive. It's always a plus sign. So that is the A and the P in SOAP, is that it's always positive. Okay, now the other thing that we need to know to be successful in using these SOAP formulas is what are some common cubed numbers so that we can correctly get the cubed roots. Cubed roots have not been as common for us throughout the year. I know we've done a lot of work with square roots, but we're going to fill in this list off to the side here. These are common cubed numbers that you're going to see so that you can fill in, that you can factor using this method. So some perfect cubes. A cube just means that the number is multiplied by itself 3 times. I did put 1 cubed in the list, even though that's probably the easiest one for us to do. 1 cubed is 1. 2 cubed really means 2 times 2 times 2. I want you on your own to go ahead and fill in the rest of these. So fill in as many as you can. If there's one that you need to check on a calculator, or you can check it when we come back together, that's fine. But this list is going to be some common cubed numbers that we'll encounter. All right, so let's double check our chart here to make sure you have all of the numbers filled in and that they're filled in correctly. So we have 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, we have 5 cubed is 125, and for the 10 cubed at the end, a fun fact about this is if you ever have 10 raised up to an exponent, the number of zeros following the 1 are going to equal the exponent that it's raised up to. So in this case, it's raised up to the 3rd, so it's really just going to be a 1 that's followed by 3 zeros. All right, so these are common ones that you're going to see. So in our first problem, we want to factor x cubed minus 8. One of the first things I like to do here is rewrite this to identify what's A and what's B, especially since our formulas are heavily based on A and B. Let's rewrite them as like what exactly is being cubed. Now the first one's a little bit easier. It's just x that's being cubed. But for the second one, I'm going to think about my chart over here and think, all right, what is the cubed root of 8? That is going to be 2. So we're going to rewrite that as 2 cubed. So now in our formula, we can see that A is going to be represented with an x, and B is going to be represented with a 2. Okay, so then we are just going to look up here at our SOAP formula, how it is expanded out, and we're just going to carefully plug in A and B where they go. So we're going to start with that binomial part. It should be A minus B as a start, so we just have x minus 2. For the trinomial part here, it begins with A squared. Well, if A is x, and it's just going to be x squared, followed by a plus sign. For the middle term of the trinomial, it's A times B, so that's just going to be x times 2, but I'm going to switch it to put the 2 in front of the x, since that's just a more common way for us to write that. And then that's going to be followed by another plus sign. Now, at the very end, when we do b squared, it's really 2 squared. You can write it as 2 squared, or just simplify that down. I'm going to write it as a 4, but maybe off to the side here, I'm just going to put a little note to myself here as a reminder, it's really 2 squared at the end. And that is all we have to do. So we're just going to identify what's A and B, carefully plug it into the formula. I want you guys to go ahead and try the second one on your own. Notice how this is now turned into a sum of cubes. We've got x cubed plus 125. Nice job on this one. So we can see, all right, x is being cubed, 125 is right here in our list of perfect cubes. So starting the same way as we did before, I like how most of you wrote it out like this. It's really x cubed plus 5 cubed, so we can really see here that in this case, A is x again, but now B is going to be 5. All right, so when we expand it out in the binomial part, it's the same sign as the original, so we know that it's going to be a plus sign, and it's just simply x plus 5. And then in the trinomial part here, it's going to be a squared, so it's really x squared, minus a times b, x times 5, we'll just write that as 5x. And then at the end here, it's going to be plus b squared. You can write 5 squared, or you could just simplify it down to be 25. So simple as that. Identify A and B and just plug the values in where they go. All right, awesome. That's the end of page 9. Let's go ahead and turn our packet over to page 10. We are just going to finish up today with 2 final strategies for factoring, and these are going to apply to some new and different kind of situations that we have not seen yet. All right, so next strategy. This one is called factor by grouping. And in just a moment, you'll see why. It has to do with grouping our terms together into 2 groups. Now, there's a very specific time that you would use this method. And it's listed right here at the top of the box. You are going to use that method when you have 4 terms. That is the only situation where this method will work. If you only have 3 terms, you can't do this. If you have 5 terms, you can't do this. It has to be 4. Now, here's how it's going to work. When we split this into 2 groups, group 1 is going to be the first 2 terms that I listed out. And I like to do a little grouping symbol. I do kind of like a little bracket on the bottom to show that I'm just going to look at that group. And what we're going to do here is take out the greatest common factor just from those two terms. What would the greatest common factor be? X squared, yes, the biggest thing that we can divide them both by. They don't have any numbers in common since it's a 1 and then a 3. But yes, if we look at the variable part, because the second one has an x squared, we can certainly divide it out as that one. X cubed is big enough to take out an x squared. And so what we're going to do is put that x squared in the front of a little parenthesis, just big enough to hold two terms. And that's going to be the result of taking out the x squared. And so in the first position here, we should just have a single x left over. And if you think about doing this with a distributive property, like x squared times x, sure enough, that's going to get us back to x to the third. Bring down the plus sign. And because we took the x squared out of the second term, the only thing that we're left with is just the 3. All right, so that is the first part of this. Now, the second group, I'm going to use my little grouping symbol. Again, it is going to be putting together the third and fourth term. Do you see something that we could divide those both by? Go ahead, Daniel. 5. And let's take it a step further. In addition to the 5, is there any other thing that they seem to have in common? The negative sign. And so if we divide them both by -5, what that's going to do is going to turn this parenthesis part to be exactly the same as the first parenthesis part. So we have an x, and then notice here that when you do -16 divided by -5, it's going to turn it into a plus sign. Now, this step right here, noticing that the parenthesis part is the same, is critical to being able to use this method. In fact, you cannot move forward with this method if those parenthesis parts are not the same. So that is absolutely to be expected. It worked out very well for us here for them to both be perfectly x plus 3. All right, now here's the interesting thing at this point. I'm going to use some colors here to help illustrate this. The first piece, it's kind of like we have two factors being multiplied together. We've got x squared, and that's multiplied by x plus 3. The second piece also looks like it's two factors being multiplied together. We've got -5 multiplied by x plus 3. Well, if we think about the work that we've been doing with greatest common factor, greatest common factor is taking out a factor that two pieces have in common. Well, in this case, they both have the factor of x plus 3. That's in common for the first part, and we also have that in the second part. So it seems a little strange because it's a whole quantity in parentheses that they have in common. But that is a greatest common factor. And what we normally do with the greatest common factor is we normally move it out here in front of a set of parentheses. And so what happens here in this method is that whatever that quantity was that was the same, it's going to condense down. It's going to be one of our final parentheses in the answer. But although it was listed twice up in that step, now it's only listed once. And we're putting it out in front because we're kind of thinking about it as being like a GCF. So the way that we're going to fill in the other parentheses is going to be the leftovers. Like, what are the factors that we were left behind? So in this case, in the first one, we left behind an x squared. So we're just going to transfer that down. And from the second one, we left behind a -5. We are going to transfer that down. And notice how I am keeping the order the same. The x squared part, that one was first, I listed it first. The -5 was second, and I listed it second. And that is our final answer right there. So when we are doing the factor by grouping method, we still get two parentheses side by side. It's just kind of a little different way for how we got there. Now we can still check our answer with FOIL. I want to convince you that this method here works. So if I were to do a little thinking here with FOIL at the end, x times x squared is x to the third. Then for the outside term, we've got negative 5x. The inside is positive 3x squared. And then positive 3 times negative 5, sure enough, gives us negative 15. So all four terms are there, accounted for, that we had in the very original problem. Okay, we're almost done. We just have one last method we're going to finish up with. This one is actually not terribly difficult because it's really similar to one of the other methods that we did on the other page. So this is what I call a quadratic-like trinomial. So quadratic, remember, it has to have a degree of 2. So a quadratic trinomial is the kind of more basic one that looks like this. So it has an x squared plus bx plus c. It's very easy to factor those. Notice how what we have here is a trinomial, but it's actually not quadratic. So if you look at the exponent at the very front, it's actually a degree of 4. We saw earlier last week, it has a name similar to quadratic. It's actually called quartic. And it turns out that if you have this kind of special format where the first term is x to the fourth, the second term is an x squared term, and then the last term is a constant, you can factor it this special way as being a quadratic-like trinomial. So it's going to behave like what we did when we factored basic trinomials. I'm still looking at the numbers here, thinking about two numbers that multiply to negative 18 and add to negative 7. Does anyone have two numbers that would work here?
Negative 9 and positive 6.
All right, that'll work. It is still going to factor into two parentheses side by side. The only difference is that instead of putting x at the beginning of each parenthesis, we're actually going to put in x squared at the beginning of each parenthesis. So if you think about the process of FOIL, that x squared times x squared, that's going to give us that x to the fourth. That's the only difference. We're still going to just put our numbers in like this, minus 9 plus 2. Now sometimes when you do these, that's all you can do, and you just stop there. Other times, there's another method that you can use to actually go one step further. So what does that x squared minus 9 look like? Well, what would it be called? Daniel? It involves perfect squares. It has two squares. They're being subtracted. Difference of squares, that's it. So look out for those. It's only going to happen here if you have an x squared minus a perfect square number, which is not always the case. But if you see it, we're going to go ahead and take it one step further. So we'll go ahead and factor that into x plus 3, x minus 3. Now, there's actually no such thing as a perfect way to factor a sum of squares, and also 2 is not a perfect square number. But like the x squared plus 2, we're just going to leave that as it is. So it's totally fine if you still have an x squared in your final answer. If you would have had something like x squared minus 5 and then x squared plus 2, you would just leave your answer like that because there's not a perfect way to continue moving forward. So those are all of our factoring methods. Our assignment for today that we'll have some time now to get started to work on, it's just going to give you a lot of practice on the different methods. You're going to notice in the assignment that the problems are all kind of mixed up, and so part of this process is being able to recognize what method do I use in what situation. And so in the notes, I want you guys to use the clues, the information that we wrote into the box about this is kind of when you would use this, and then we're just going to kind of try it out and see how it goes.